Hi, this is Tavi Greiner, Astronomy.FM's Vice President of Communications. If you enjoy our programming, please let us know with a donation to Astronomy.FM/donate. We really do rely on your support, and it's true, every little bit counts.
AFM.
Program complete. Enter when ready.
The curtain of night is drawn back. The telescopes are trained. The domes are open. The audience is set. Now, step into the event horizon.
Good evening, everyone, and welcome to the Event Horizon here on Astronomy.FM radio. It is another Friday evening. This one happens to be April the 27th, 2018, 9 o'clock in the evening for those of us here in the eastern portion of North America. So Universal Time, that would put it at 1 o'clock in the morning, Saturday morning, April the 28th, 2018, Universal Time. And it means we are live for the next hour. So come on over to our Astronomy.FM chat room. Just go to the homepage, Astronomy.FM. You'll see near the top there where it says Radio Chat. Click on that. Type in a name, skip the password, completely leave it blank, hit login, and you'll be in our chat room. If you want to ask us questions, feel free to do so, because we're trying to watch the chat room and trying to answer your questions if we can catch them at the right time. It's kind of hard to talk and read sometimes for me.
Yeah, Glenn's already putting links into the chat room already. Yeah. And ironically, this is a story we're actually going to tackle, but from a slightly different angle. Right, okay, so in the chat room, Selby, Glenn, Starstorm, Black Projects. Great to see you here, Black Projects.
Mm-hmm.
Myself, and of course, Marty. Oh, and Aqua for You has just
joined us. Yep.
Yes. So, right, what's happened?
It's all right.
2020 lunar rover cancelled. Why? Well, no official reason yet, but I have the Washington Post story as well. And so Glenn posted the MSN version, and I've got the Washington Post version. So anyway, months after...
And I've got both links.
Thank you. Months after President signed a directive ordering NASA to return astronauts to the moon, guess what NASA did? They cancelled its only lunar rover currently in development. Now, according to Clive Neal at the University of Notre Dame, this is planetary science there, and the Erasmus chairman of the Lunar Exploration Analysis Group, members of the Resource Prospector mission were told to close out the project by the end of May. Obviously, he's a bit shocked. He's not directly involved in developing the mission, but he says he didn't know the reason for the cancellation. What I don't get is this is going to one of the most interesting portions of the moon. It's going to one of the lunar poles.
And what's so important about that?
Because they are the places where there's good old H2O.
And why is that?
Because if you're going to live on the moon, the biggest problem you're going to have is finding drinking water. Because lifting bulk water is going to be expensive. Shifting gases to spark in the dome to create water is a pain in the backside, proverbially, because you've got to really watch what you're doing, because hydrogen's explosive in oxygen. And apart from that, if you can find it already there, that's one less thing you really have to worry about shifting.
So how did the water get on the moon when the moon is supposed to be completely water?
Well, it's mixed in with the regolith. Now, the thing is, the great thing is, of course, there's comets been hitting the moon. There's been asteroids, micrometeorites. They all hit the moon. It's an ongoing process. It's not as great as the late Great Bombardment, which was a couple of million years ago, which created the mare, the craters that we currently see. Interestingly, the face we see is the most heavily cratered part of the moon. The far side isn't as badly cratered as the front, as our side was. Interestingly enough, there's also the crust is slightly different. Now, we when you look at the moon, you obviously see the great grey patches there, the mare. That is lava flooding that's come out of the moon itself. Some cases probably in response to a bombardment. Now, the really sad thing is, I suppose, really, is that this mission A, it would get back there before we do as humans, and B, it would be prospecting the possible moon-based site, because once you've actually got a guaranteed source of water, even if you've got to process it, it's one less thing you have to worry about. The other good thing, of course, is by going back to the moon, it allows us to test technology which would obviously be used on a future manned mission to Mars. So I guess what they're saying is, well, if we're going to go there ourselves, we don't need to send a robot. I totally disagree, because the whole point of this mission is to pinpoint where the best places are going to be to put that place.
And sometimes you can't just use the Mark I eyeball.
No, you can't. The robots can cover an awful lot more territory than humans can, unless, of course, you're going to give them a completely and utterly new lunar rover. Now, I do happen to know that Captain Slow actually tested one that NASA had under development.
Oh, dear.
And he got into trouble with it because he got it stuck, and that was just on a road on Earth, going around, I think it was Houston Space Center. So if Captain Slow can get into problems, Lord help the astronauts.
Now I gotta find that episode.
Now explain why there's still water on the moon.
Because
and where it's at.
It's at the south. It's at the polar areas, because it's where the sun doesn't really get to shine very much. This is going to be in craters, and it's going to be in those parts of the craters that don't get direct sunlight. Because when the lunar temperatures drop, they drop. And when the temperature rises at lunar sunrise, it goes straight through the roof, basically. It gets very, very hot very, very quickly. This was one of the couple hundred degrees, yeah. This was one of the reasons the astronauts really did have to take time out on the lunar missions to rest, because it was a very stressful environment. And by being out during lunar daytime, it puts a major stress on the backpacks.
So makes you wonder that these could not have had solar panels on this rover, because it wouldn't have worked. If it was down in the crater, down deep in the crater that never got sunlight, then there's no way solar panels would actually be able to work for these rovers. So they would have to be either short-term battery powered or some sort of a nuclear fuel type of battery system.
Well, we're probably going to be looking at going back to what we used to power Voyager, which is the Snap 90s, the plutonium-based batteries. We've proven the thing. This is what gets me. When we launched those missions, everybody was complaining that if something goes wrong, you're going to spray nuclear waste over the whole area. Well, obviously, what they did do prior to the mission, and as part of the development of the space probes that carried them, was they tested the containment vessels to make sure if there was a catastrophic failure at launch, they weren't about to contaminate either some part of California or a part of Florida with the nuclear waste, nuclear fallout. So, you know what, as I say, Starstorm, Black Project is reporting out James May visits NASA Top Gear, Series 16, Episode 6, yes. I think it was also, I think he got into that vehicle also on that DVD where he actually gets to fly up in a U-2, but I could be wrong on that one.
Frankly, spreading radiation all over the surface of the planet is really not necessary to use a space mission to do that.
No, it isn't.
Plenty of ground-based methods to do that.
Yeah, plenty of ground-based methods. Interestingly to note that the British nuclear authorities, they actually tested a nuclear waste containment vessel by ramming a diesel train engine into it at full speed. And the actual vessel, it was knocked off the tracks. It went off the tracks. James May on the moon. But the actual containment vessel itself was not damaged. It was scraped and scored, but there was no physical damage. This is what they use in the UK every single day to transport nuclear waste to what used to be called Windscale and is now called Sellafield in Cumbria.
So basically, don't try to race the train if you're carrying nuclear.
Well, as I say, this was they decided that it was actually much safer to transport nuclear waste by rail than it is by road. And even a collision between another rail user was not going to be a big issue. They really built these things for survivability, and pretty much the containments used on the space probes that have plutonium batteries was built to the same specifications.
So I hear there was a big argument about where to actually land the rover, and finally somebody says, well, why don't you stick it where the sun don't shine?
Well, yeah, Shackleton Crater, basically.
There you go.
That's one of our real spots for water. And this was one of the places that was, I do believe, that LRO looked at in great depth. So did the Chinese mission, the Indian mission, and the Japanese missions. They all spent a lot of time looking at Shackleton Crater and its eruptions because that is where they were seeing the signatures for water.
I see a picture of the rover. It kind of looks like, I think I've seen this before in my neighborhood up on blocks. Looks just like that.
Yeah, basically someone tried to nick the wheels from it. But the one that we're seeing on the Washington Post was a simulator version of the Resource Prospector. We're never going to get to see it happen now, which is really, really sad. But then again, I suppose that's what's happened. I really think that the head of NASA should have a 8 to 10 year term, and only be fireable if he or she is really screwing it up.
You'll find out. It's not the head of NASA.
Yeah, I know, but
that's changing missions like this.
Oh no, it's the government. We know that.
Yep.
But the thing is, I'm thinking maybe it's time we had better continuity of leadership at the top. And unfortunately, as always, being the head of NASA is a political appointment. And I do believe the only person that survived a change in governments as a NASA director was James Webb himself.
We got a question. Does the vehicle have a shifter? No, I don't think so.
No, it won't.
because it would be, I don't even know if there's any transmissions, or usually they're just one speed only. I don't even know if it would be variable speed or not. That would be
it wouldn't be. The only thing that had variable speed was the actual Apollo lunar rovers. And I've just had it pointed out to me and reminded, at the moment there is no current head of NASA. There's no NASA administration.
Just got recently appointed, I thought. I saw on the NASA homepage. We'll check that out in a minute.
Yeah.
Well, if they're electric motors, though, the variability would be in the applied voltage or chopped voltage, either way.
But maybe Black Projects can confirm this or otherwise. I do believe that the lunar rovers we had during the Apollo era had the ability to had a variable speed on them. I do know that there were some films, some movies taken showing of the rover actually going at quite a good rate and then slowing down and then speeding up again. But I think that I really, really have to say I really loved that lunar rover. I thought it was absolutely brilliant. It was kind of four wheels, electric, variable. Glenn thinks. But you know what? The old lunar rovers that NASA had back in the Apollo days, they were absolutely brilliant. They were reliable. Thank you, Starstorm. And they really did do the job. I don't think they were actually designed to be beach buggies and drive like beach buggies, but by gosh, they did.
Well, maybe if the Rovers Council, maybe they could just buy one of those, what they call little rascals. For senior citizens to ride around on. Maybe they just send one of those up there. It's already built, already battery powered, and they're a few $100 a piece or so. Probably send 4 or 5 of them up there. Just let one run until its battery goes out. Let another one go until its battery runs out. Or put, like you said, the radioactive battery in there should be, it's already built. Just let it go. Cheap enough.
Yeah, build the science experiments onto it.
Yeah, there you go. Basically, have a garden hole on the back of it, just dragging up some of the dirt. Churn it up and point a camera at it.
Hey, I got a better idea. I know totally the thing we need to send.
What do we need to send?
A John Deere.
Did they make those electric?
Yeah.
Oh. Maybe. We'll check that out.
Yeah, I'm sure John Deere probably would think, "Oh no, please don't touch us for the job."
Well, that actually might work. We just need sponsors. We can get a corporate sponsor to build a rover. They just got to put their logos on it. So might be a little competition there. Mm-hmm.
Oh yeah. Glenn says call AAA.
There you go.
Yeah, I could just see that. Okay. Black Projects has put 2 links in. One is a Wikipedia link to the lunar roving vehicle.
Okay.
And the second one is a video on YouTube of the lunar rover. Brilliant. Thank you, BP. Appreciate it always. I like the Apollo lunar rovers. They were just fun. And I think
they looked fun, but
well, the thing is, from what I understand, listening to some of the interviews with the returning astronauts, they were actually able to do things with it that weren't really in the design schedule.
Like get airborne?
Yeah, like get airborne.
Wait! You can't get airborne on the moon, though.
Well, you can get moonborne.
You can. Yes.
Oh dear.
Yes, this is going to be one of those nights, folks.
Those craters would be perfect. Yeah, you can go start at the top one, go down, hit the other rim, do a flip, go the next one.
Well, the thing is, I can't remember if it was Apollo 16 or 17, that one of the trips out in the rover, they hit a bump and they did actually fly a few feet.
Mm-hmm.
But that just shows you just how well built it was. When it landed, it kept going.
1/6 gravity.
It always helps.
A little less of an impact that way too. Yep.
But anyway, it's really sad that the next American rover is not going to go. Obviously, the Taikonauts may actually even get there before we do. And to be honest, I'm gonna be very totally unpolitical and say good luck to China. I really hope that they successfully do land on the moon, and look forward to the science that they're going to release. They have been very, very good. Their Changi probe images and stuff were released very, very quickly. And that was really excellent, that they were as fast as the Jackson mission, the Cayuga stuff. So they put stuff out very, very quickly for the public to see.
Mm-hmm. I looked up the weight of the rover. It's like on Earth it was a little less than 500 pounds. On the moon, only 77 pounds.
Yeah. In fact, Black Projects has put a link. It was Apollo 16, LRV Grand Prix. Now there's something we could do. Get maybe 2 or 3 landers together, each with our own rover, and have our own Formula One moon rover race.
Oh boy!
Gotta find a good flat spot though.
Can you imagine? You can hear in the background the chain.
Can't hear anything.
Mac over your radio that you got the chain playing from Fleetwood Mac.
There you go.
They get by the start line, and you've got your astronaut, cosmonaut, taikonaut, whatever naut, standing there with the checkered flag. And Murray Walker is saying, and here we go for the first race on the moon. And they're off. And it's Lewis Hamilton in the British rover entry. He's stealing a fast lead on the Italian Ferrari rover, blah, blah, blah. It's something that you can conjure with your mind. It would be brilliant. To be honest, I would like to see a lot more of these missions being multinational. I know everybody waves flags and says, oh, we can't share technology with so-and-so and so-and-so. Well, you know what? At the end of the day, if we're going to do things like Mars, and Elon Musk surges ahead in his Tesla. Yeah, I can just see that now. He got enough flack over launching the thing out to the asteroid belt.
Oh yeah, that's just thinking. He launched an electric car into space.
Yeah,
you could have put that thing on the moon, or somebody could.
He could have gone to the moon, and it could be racing around right now.
It could be racing around on the moon right now. Yeah,
and of course, you know who's going to be driving it, don't you? It's going to be the Stig. We're going to have the Stig road testing the Tesla on the moon. Oh, boy. I could just see Jeremy Clarkson. And so we gave our spaceborne Tesla to our top test driver. They say that he was the love child of Bella Lestrange and Lord Voldemort, but we know him as the Stig.
What was the name of that show?
Top Gear. Top
Gear, that's right. The UK version, though, right?
The good version.
The good version.
That's what I've never heard of. Whoever you're talking about.
You can actually get it. Top Gear is available on DVD, Blu-ray, and it is found to be streamed in very good places.
There's Richard's asking, wonder if the Tesla would actually work on the moon.
I think it would need special. Well, we know it's going to need specialized tires, because that's the first thing they had to do with the Apollo lunar rover was design a wheel and tire that could actually cope with the conditions. Well,
that was more of a weight restriction than anything else, though. So they couldn't make solid tires, so they had to bring basically make it as wire. What's the word I'm looking for? Screen material, like mesh. Yeah. So, the Tesla launched with its tires, but I can't remember. Obviously, the air was probably out of them.
Yeah.
Or did they fill them, make them solid?
They would have made them solid. They would have put solid rubber in there.
Well, shouldn't be too hard. We've got technology to, launch the weight and stuff like that.
It could be done. Be interesting.
And
well,
certainly
the
price,
heavy, yeah.
The price of the price of the vehicle would be certainly well known. Probably much underneath the price of a custom built, titanium.
Yeah.
Bare minimum weight vehicle. So that would be interesting. In fact, we should be. Somebody said what about a rover that would go, check out some of the lava tubes on the moon. Like, wow, yeah, there should be like a plan instead of one rover barely getting to the moon. How about a mission where we get 10 rovers on the moon?
Well, yeah, why not do that? Let's do it.
Because let's start cranking them out and getting them all over the moon. That's what they really should be doing.
The really great thing is, if it's going to go into the lava tubes, give it legs. Make it into a spider, so that it can literally walk into the lava tube and then back out again. Yeah. Oh my God, that was a hamster comment.
The tubes, I think, are quite long, so going in would be just fine. Except you probably lose your radio communication, so that'd be a different issue, though. So
give it an AI. Give it an AI that can think for itself, that knows, okay, I'm no longer in contact. I've now got to store all the information I'm getting. I've got to a point I can go no further. So now I'm going to back out, re-establish contact, and send all the information home. Oh, that was Vigil, wasn't it?
Or just drag a wire and a spool.
Yeah.
That could work too.
The other thing that's commented on is the golf ball. So, Alan Shepard Jr. played golf on the moon. He took the actual club part with him. He tacked it to his test probe.
Shovel handle or something?
Yep, and then played golf on the moon. I have to say, a lot of people are probably going to laugh. Typical Navy pilot. But no, seriously, it has a valid scientific. It's scientifically valid as an experiment. It demonstrates gravity.
Mm-hmm. Didn't they drop a hammer and a feather too on the moon?
Somebody? Yes, they did. They did all the classic physics experiments, basically.
And they both hit at the exact same time.
Both hit exactly the same time.
Yep.
So all right, let's roll. The physics are the same on the Earth as they are on the moon.
Let's rover off the moon now.
Yes. Oh, shall we go into the inner solar system quickly?
The inner solar. Yeah, let's go very, very inner.
Okay, you go to the sun, and I'll take over, and I'll go next to the sun afterwards.
All right. This past week or so, there's been one tiny little sunspot, active region 2706. Finally gave us a sunspot after months with no spots, something like that. But it was a tiny group, about half a dozen spots or so. Looks like it's kind of faded to nothing now. So just an active region. A little bit of stuff, but nothing special. A little bit of coronal hole. That means in the northern portion of the sun. That means where some extra particles are streaming away from the sun. And we're kind of getting a little bit of extra particles from the sun right now. So wind speeds are just up a little bit at only 400 kilometers per second. That's still pretty low. Density is up from about 1 till 3 protons per cubic centimeter. So just barely a little bit of particle streaming from the sun right now and in one faded sunspot. So nothing too special the sun right now.
And of course, if you're in Iceland and you're looking for aurora, you're out of luck. It's now the land of the midnight sun.
Definitely, yes.
Okay, moving from the sun to the next object in the solar system, it's our old friend Mercury.
It is.
Now, Mercury is small, it's fast, and it's close to the sun. So yes, it's a very challenging little rocky world to visit. Only one probe has ever orbited the planet, and it's collected enough data to tell scientists about the chemistry and landscape about its surface. So obviously that was Messenger. Now, interestingly enough, even though that probe's missions ended in 2015, planetary scientists actually now estimate that Mercury's crust was roughly only 22 miles thick. Now, obviously, one scientist at the University of Arizona disagrees. Now, they're saying using the most recent mathematical formulas, lunar and planetary associate staff scientist Michael Sori estimates that the mercurial crust is about 16 miles thick, and it is denser than aluminium. His study, A Thin, Dense Crust for Mercury, was published on May the 1st in Earth and Planetary Science Letters, and it is available online. So, Sori reckons that he's managed to work out the density of Mercury's crust using the data collected by the Mercury Surface Space Environment and Geochemistry Ranging (brackets Messenger) spacecraft. And he created his estimate using a formula developed by Isumu Matsuyama, a professor in the Lunar and Planetary Laboratory, and University of California, Berkeley scientist Douglas Hemingway. Sori's estimate supports the theory that Mercury's crust was formed largely through volcanic activity. Now, the thing is, understanding how the crust was formed may allow scientists to understand the formation of the whole entire oddly structured planet. Of the terrestrial planets, Mercury has the largest core relative to its size. Mercury's core is believed to occupy 60% of the planet's entire volume. For comparison, the Earth's core only takes up roughly 15%. So, why is Mercury's core so large? Well, maybe it formed closer to a normal planet, and maybe a lot of the crust and mantle got stripped by giant impacts, Sori thinks. Another idea is maybe when you're forming so close to the sun, the solar wind blows away a lot of the rock, and you get a large core size very early. That's not an answer that everybody agrees to yet, but Sori's work may actually help scientists in the right direction. Already it's solved a problem regarding the rocks in Mercury's crust. So, as I say, the greatest thing is we've never really known much about Mercury. And now we're actually beginning to find out a lot more. We've got spectra, we've got a topo map of Mercury. And of course, Mercury, if you can get it before the sun rises, when you're lucky enough to, you may actually be able to get an image, and you may actually see phases. The only other thing we know that does that is the moon and, of course, Venus.
Well, right now, it just so happens actually Sunday be the best day. Mercury is at its farthest distance from the sun Sunday morning, a whopping 27 degrees, and that's actually pretty far. Unfortunately, though, the angle of the ecliptic that it's on keeps it pretty low from our northern hemisphere perspective, keeps it pretty low along our southern horizon. So about sunrise or so, Mercury is not much more than 5, 6, 7 degrees above the horizon, something like that. So it's pretty far from the sun, but not very far above the horizon. Southern hemisphere observers are going to have a really great chance of seeing Mercury, but everybody else, yeah, you got a chance. It's it's far from the sunlight, so give it a shot. And as I always try to promote people with telescopes and taking caution, look for Mercury during the daytime. It's definitely possible. 27 degrees is pretty far keep it safe. Keep like the sun in the shade of a building while you're looking for the planet Mercury, and you'll be able to find it if you're, with a little bit of diligence. I've seen it in the daytime quite a few times. So I've seen it more in the daytime than I have actually in nighttime.
I can believe it. Now, Aqua for you, Red Shirt 3, great to see you, mate. Evil Spock and Optronics have joined the chat. Nice to see you here, guys. Now, do you want to do the station ident, Marty, and then we'll do a special event that's happening this Sunday? I will
do that. You are listening to the Event Horizon here on Astronomy.FM radio. It is another Friday evening. This one is April the 27th, 2018, about 9:30 in the evening for our eastern portion of North America, halfway through our program right now. Universal Time would put that at 1:30 in the morning, April the 28th, Saturday morning. So we're still live for another half hour. Coming up after the Event Horizon, we've got more programming. We've got Sky Talk, and stick around for about 10 after, less than that, after the hour. What was it? Churchill and
Churchill's Extraterrestrials.
Churchill's Extraterrestrials. I'm going to stick around and listen to that one, that's for sure. So more programming. We got First Light coming up. We got a full 4 hours of programming that we repeat every 4 hours for the next 24 hours. So a lot more stuff to listen to after our program. So stick around. I want to say hi to everybody in our chat room. And, of course, an open offer for anybody to come on over to the chat room. You can go to the homepage where it says Radio Chat. Click on that. Just type in a name. Hit the word login. Forget the password. Just hit login, and you'll be in our chat room. If you want to ask us questions, feel free to do so. We try to read the chat as we go along and try to answer your questions if we can.
And if we can't answer it this week, we'll answer it next week.
Or after that, we won't, because we'll forget.
Now, interestingly enough, this weekend is a very interesting. It's a very special conjunction of the Moon and Jupiter. So this weekend, the Moon and Jupiter are converging for their brightest conjunction of the year. Let me just put this link into chat. Just 1 second. It's from spaceweather.com.
Okay.
Now, so the Moon becomes full on Sunday night, April the 29th, and only about 5 degrees of arc will separate the pair inside the constellation of Libra. So you need to be looking southeast after sunset on Sunday, and what you will see is just above Libra is the Moon, with Virgo above that, and in the triangle of the head of Libra, or the top of Libra, which is the actual balance, you will see Jupiter.
Mm-hmm. Blazing away.
Blazing away as always.
Don't forget your telescopes and your binoculars to see Jupiter's moons.
Yep. And, of course, binoculars are really good because they will show you at least the Galilean moons. And you'll get a decent view of Jupiter that way. And I'm going to be honest, don't rush out and buy a telescope first thing if you're getting into the hobby. Buy a pair of binoculars. Get a nice pair. Get a pair by 20 by 80s or 20 by 50s. Buy a tripod, or see if they come with a tripod, because I'll tell you what, it really will make life a lot easier. And of course, if you suddenly decide you don't like astronomy, you can always go bird watching with them.
Well, you said 20 bys, so 20s are a little bit tough to start out with because they have a rather narrow field of view and can be kind of heavy. So your typical 7 power binoculars, which is most of them, wide field with nice clear edges, really good. That's what I got. And 30 or 35 or 50 millimeter lenses in the front. So it would be like 7 by 35 or 7 by 50. A good general pair of binoculars to start out with.
Well, I started using my 7.5 by 50s. I think, no, they're not. Hang on, let me reach down.
Should be 50s.
No, they are 7.5 by 42s.
Okay.
So it's
somewhere in between.
367 feet at 1,000 yards.
Mm-hmm. So, main thing is when you buy a pair of binoculars, which I used to work in a store that sold binoculars, and I got to look through all of them, is a wide field of view, because the power is basically all the same, 7 magnification. That's pretty much it for the general types of binoculars. The other one, 35, 42, or 50 millimeters, that's just the lens opening, how much light it gathers. Pretty close. But one important thing I found out was the clarity near the edge of your field of your view. So when you look at them, everything in the center is pretty focused. But when things get off to the edge, sometimes they get distorted. So what I used to do for testing binoculars, I would point them at some power lines.
Yeah.
The power lines are nice and straight. Well, if you're looking at the power line and they start getting wider at the edges of your field of view, then that's distortion in the lenses. So try to find something that will keep a power line nice and straight all the way across your entire view. If you find something like that, again, and look at the numbers too, what was that number, so many feet at 1,000 yards? Yeah, the bigger that number of feet, that means the wider field of view.
Okay, on my Osprey, Swift Ospreys, it says high resolution, 367 feet at 100 yards.
100 yards?
Sorry, 1,000 yards. Beg your
pardon.
There
you go. Yep. Basically, that's how big of an object you could see. That would be 1,000 yards away, and you could fit the entire object inside your view.
Well, as I say, those were actually really for those binoculars I started out with are really for bird watching.
Mm-hmm.
But you know what? They are a good start. And at the end of the day, most of the shops that sell binoculars are going to be fairly okay. They may actually send an assistant out with you, stop you running off. But they understand what you're doing and why you're doing it.
Mm-hmm.
So at the end of the day, it's just really a case of, we understand that, we will help you. Because they want you happy. They want you to come back and eventually spend the big money on the telescopes. And I'm going to say this. Don't ever buy anything that says for a small refractor, it's going to give you a colossal view of the Andromeda Galaxy. It's going to give
exactly.
you a 200x view. I'm sorry. That's just the biggest load of ever. At the end of the day, you might get some. It's going to be a very narrow field. You may get a decent view of the moon, and you may get to see some of the larger craters. You'll definitely get to see the mare with it, but that's about it. They are not going to give you a stunning view of the Andromeda Galaxy. The only way you're going to get that is you're going to get a small telescope, a decent small telescope, about 4 inches, a decent Newtonian.
Or log into the Hubble site.
You can log into the Hubble site, yes. And you're going to get a camera. And you're going to either use a DSLR or you're going to use a CCD. And then you're going to take all your lovely pictures. You're probably going to shoot a good couple of hundred. You're going to shoot your flats, your darks, your lights. And then you're going to spend the next 3 hours processing. That's the only way you're going to see the actual colors and greatest detail in the galaxy through a telescope. The human eye, given the distance of the object, will not. Yes, you will get to see a good outline of it after looking at it, possibly through averted vision, for a good while. The longer your eyes get adapted to the dark, the better off. But you are not going to see it in stunning color, and it certainly will not look like what the label of the box says.
One comment I would make on binoculars is don't trust the guy behind the counter.
No.
Look through them, because they'll go, yeah, these are the most expensive, so they're the best. And I have found that not to be true. Now, I did pay a higher price for my binoculars. They were over $200. But I looked through all of them and did find the best pair that gave me the clearest view all the way out to the edge with an extra wide field of view. I wish I could find them around here. I'd tell you what the numbers were on them. So.
I've got a set of astronomical binoculars from Zahemahel, and it comes with a tripod.
Mm-hmm.
Now, I to be honest, I actually use them to look at the moon. And every now and again, if I'm near an air show, I'll probably use them for an air show. But the thing is, that's great. It means I haven't got to worry about getting a telescope out. I can just set the binoculars up. They can cool off a little bit. I can go out. I can crater hop. I can look around in the mare. But that's what I use them for. Mm-hmm. No, I'm happy with them because and to be honest, I didn't pay $200, $300, $400. I think I paid about $100 tops, and that included the tripod.
Mm-hmm.
And to be honest, a tripod is really, really an essential because
for bigger binoculars. Definitely
for bigger binoculars. And to be honest, I've used tripods on my bird watching binoculars, and it really photo tripods don't work very well. But
they work fine. I used photo tripods just fine.
I think it really depends how good the tripod is.
Obviously.
If you're gonna buy, my tripod is from Silk. It is designed for a professional photographer. It pans, it tilts, and it can be locked in place.
In big bucks.
No, actually, I think the most I paid for my Silk tripod was about $40. Well, £40.
That's pretty good.
But the Silk, although they're not an expensive brand, they're a quality brand.
That's the point. Like binoculars and any equipment, get something that's quality, which is not directly related always to the price.
No, it isn't. You can get some really good stuff without breaking the bank, literally. Obviously, as soon as you start getting aperture fever, yes, I have aperture fever. But the thing is, I know what I'm doing. I know what I want the aperture for. I'm at the point now where I don't just want a crater hop. I want to start looking for domes. I want to start looking for rills. I want to start looking at mountains and escarpments. And you really do need an awful lot more power than the average pair of binoculars is going to give you.
Definitely.
That and the fact I can also then, if I really get okay, fine. It's new moon. There's nothing. It's not in the sky. What am I going to do? Oh yeah, I'm going to go for comets. I'm going to look at some nebulae perhaps, but I'm going to be using a camera.
Constellations,
yes. You can image constellations quite easily.
Yep.
With a nice big LED, with a nice big mirror.
You have gone to the dark side.
Absolutely, and we have CCDs and Cadbury's drinking chocolate.
And cookies.
And cookies.
And I choose to bake.
See, this is the way to do astronomy. Drinking chocolate, CCDs, and homemade biscuits.
There you go.
Can't beat it. Keeps you nice and happy and alert, awake. And the thing is, if you're not enjoying it, what the heck are you doing it for? At the end of the day, that's why we do it. That's why we go out and we look at the stars, the planets, the nebulae, the galaxies, the moon. It's because we enjoy it. And that is the whole reason for doing it. Now, I'm told that GarySelenek.com has a great small binocular mount. So check it out. Thank you, Redshirt 3. Good recommendation, that. If you're a student and you're starting out, check out places like that. Because these guys, I don't think Gary is really in the mood to sell you bad stuff, because he's got a reputation as being a very good astronomer, and he isn't going to start selling tat.
Save up.
Save up, yes, like I did. Oh boy, yes, like I did. It's taken me 40 years to get to the point where I can actually buy a humongous telescope that I'm probably going to spend the rest of my life enjoying. I'm not going to be buying another telescope in the rest of my life. Well, Marty,
that's like a musician saying he's not going to buy another guitar. You know,
The thing is, Marty, if you're buying a 0.5 meter telescope, at the end of the day,
you still want more.
Yeah, I can't see me getting a 2 meter or a 1 meter. I've got nowhere to keep it.
Yeah, just because you don't have it. But if you had it, you would keep it. So definitely, if you could get a 1 meter telescope, you would take it. The other problems about, where it's going to go, stuff like, no, get the big telescope first, and then buy the house to put it next to the telescope.
Yeah, that could be fun.
Don't worry about it.
Or just buy a farm.
Get the big telescope. There you go.
As you can tell, I have brought my daughter up properly. How to have a telescope by a farm, because then you're out in the sticks, you've got dark skies, hopefully, and you haven't got any worries about nosy neighbors.
Yeah.
And you got food.
You always have to worry about buying the farm, though.
Yeah. You can pay the mortgage off by growing food and stuff, she says.
Yeah. Different definitions. A couple of alert notices from the American Association of Variable star observers, AAVSO. Let's go with the older one first. Currently an outburst of a star called AG in the constellation of Draco. Brightening and dimming. It's getting brighter and brighter. Was observed at 11th magnitude. Now it's around 9th magnitude. So they want people to watch this star a lot and turn in reports a lot. Now, being in the constellation of Draco, it's definitely way up in the northern sky, so southern observers won't be able to pick this one out, just northern hemisphere observers. So get out and start doing some observations of the star that's actually growing brighter. I think it wasn't this bright for about a year now, so it takes a while, and it fluctuates too. It's a symbiotic binary system.
Ooh,
2 stars.
Fun.
And the other notice is fast photometry of symbiotic candidates requested. Several candidates, actually. They've got 5 stars that they want amateur astronomers to watch. I do believe these might be cataclysmic variables, which means they could kind of brighten up at any time. So they need some photometry on these stars now, and then they'll compare them if they get if they go up and flare up. That's what I wanted to say. Citizen science, help the pros.
Hey, you can't beat citizen science, and to be honest, it doesn't. Go on.
We usually have the time and the equipment.
Yeah, that's
Exactly.
right.
And that's the greatest thing about having the equipment is because they're using your results. Not only do the pros have their names on the papers, your name's on the papers. And that, to me, is the most important thing, I think, really, is that you actually get to have your name on a PhD or higher grade paper.
Mm-hmm.
Now, I was actually doing...
I'll say, well, if you're not a good astronomer, you spray paint your name on something.
Okay, now...
I got my name on that space probe. There you go. That mission.
Yes, I think most of the time when they start putting do you want your name to go to the stars, I put my name on it.
Yep. And mine.
And you put your name on the sun probe?
Yep.
Did you? I did too.
Yeah, I did. It's going to be quite fun. Mm-hmm. Now, see 2017 K2 Pan-STARRS. It's a fuzzy but small. It's got a nuclear magnitude. The G magnitude unfiltered is about 8 inches aperture radius. M2 equals 18.2 plus or minus 0.2 mag. It's currently at about 14.4 AU, but it is getting interesting. So this is something I think if you're into comets, keep an eye out on.
What's it called?
It is C2017 K2 Pan-STARRS. The other one to keep an eye out for is C2010 U3 Bottini.
They have the potential of getting close to us. Is that why we want to keep an eye on them? Or
they have the potential of brightening up over the near future. I am saying near future. I am not promising you a naked eye comet.
Okay. Let me go to my comment list here. Weekly information about bright comets. Let's see, we got Su-16 M1 Pan-STARRS, R2 Pan-STARRS. Which Pan-STARRS was it you said?
K2.
K2? I don't think I've got K2 on my list.
Yeah, it's 2017 K2. Now, the other one I have been keeping my beady little eye on is 66P. And that has been producing a very strong green coma.
A little faint, though, about 12 magnitude yet, 11 to 12.
It's faint, but it is getting brighter. That's all I'm going to say on the matter, because I'm not going to jinx it and suddenly have it disintegrate or just completely decide, no, I ain't going to show off anymore. Switching off. Goodbye.
It's heading in the southern skies, so that's remote telescope territory there.
It is remote telescope territory, so... But another good one is C2016 M1 Pan-STARRS.
Mm-hmm.
Now, from what I understand, Kevin Parker has been imaging this, and he's put out a cracking little image. And let me just save the link, because he puts his pictures up on Astrobin, and there we go. That's the link. So that's Kevin's image of C2016 M1 Pan-STARRS, and that was taken on April 23rd. It's about Magnet 10 in the morning sky. It is quite beautiful.
Mm-hmm. Nice. We need some good comments, though.
We do. And it's like everything else. It's relative, yes. And, of course, it's really a case of totally a matter of luck. Now, the other one I've seen is Comet 74P Shimona Chanaka. It's got a short dust tail, and there is a Flickr. There's a picture up on Charles Bell's Flickr account. I'll just grab that just 1 second.
Okay.
And I'm getting Jeopardy over here.
So some comments are out there, but still faint and far between.
Yeah, but the thing is, with comets, unless they're seen close to perihelion, and they're in the right position, you got to remember sometimes perihelion happens on the wrong side of the solar system for us.
Mm-hmm.
So unless we're really, really lucky and it's on our side of the solar system, and it's a case of it's in our hemisphere. If not, fine. I will simply just log into Siding Springs and set up a mission down there and image it and have a bit of fun, and then process it and like it. Now, I've just got to quickly just check something. There is. Oh, we've just been told that the information I was given earlier was wrong. Okay, so let me put a link in there.
Is this for the Jim Bridenstine? Is that announcement? Officially took office as the 13th administrator of NASA on Monday.
So we finally got NASA, running properly anyway. Well, at least it's got a head.
Mm-hmm. There you go. All right. Let's see. Where did we want to go? We got to do this Stellar Thief article. Mm-hmm. That one's kind of like all over the place there. What that means is there's a supernova in a galaxy far, far away. In fact, 40 million light years away. In the galaxy, with just a designation of New General Catalog 7424. It's in the southern constellation of Grus the Crane, and the star blew up 17 years ago. So astronomers have been watching for it as it shrinks down and fades out, and trying to see if there's what's there after all the main light fades away. See if there's anything still there. Well, what they found was another star.
Mm-hmm.
So it turns out there was two stars in orbit around each other. One of them blew up, and the other one is still there. Some unusual conditions about these stars is that one star basically stripped the hydrogen off of the other star. And the one that had its hydrogen stripped off turns out was the one that actually blew up.
Mm-hmm.
So they had some interacting stars, and then one of them blew up, and the other one, the one that stole all the hydrogen, was still there.
The thing is, for amateurs, this is an area where, the big sky surveys are always looking for them. They always see them in most cases. However, you can do your own sky patrols, but you really do need to know your constellations. You need to know the sky very, very well. So when you see a novae or a supernova, you know where it is, you know what it is, because sometimes it may just be a case of seeing a new star, which is what a nova is. It's called a new star. And if you know that there's not supposed to be something there, or if there is something there, it's normally very, very faint and beyond vision, or beyond the telescopes, then that's when you can jump in and get something done, and maybe even get part of the recognition for yourself. A lot of people do actually automate their own telescopes. They scan the images early in the morning over breakfast, and that is one way. That's exactly what the big sky surveys do. They have people sitting there looking at pictures from the night before and looking for things that weren't there the previous night.
From the Earth, we haven't seen a supernova, naked-eye supernova, in the Milky Way galaxy for over 400 years. Now, for Southern Hemisphere observers, there was one back in 1987, just outside the Milky Way, in the Large Magellanic Cloud, I believe it was. Supernova was visible from the Southern Hemisphere. But that technically is not, and naked eye also, technically not in the Milky Way. Several close-by galaxies have had supernovas, a couple of them in M82, rather famous one in the Big Dipper region. The closest big galaxy to us, Andromeda, we haven't seen any supernova going off there, so we should be able to get some decent ones coming up kind of soon. That'd be nice. We can't get a good comet. Maybe we can get a good supernova popping up.
Maybe the thing is, if you're out there looking and imaging galaxies and stuff, you may actually get it without realizing it.
Mm-hmm.
But as I say, this boils down to how well do you know your constellations? Because at the end of the day, if you really know your sky well, and you've learned to constellation hop and use other stars to get to other stars, to get to Messier objects, to get to nebulae, then you have a really good chance of catching it. So you may not beat the big boys, but you may beat a lot of other amateur astronomers because you know the sky very, very well. Now, okay, someone's going to say, well, I'll just hold up a Google Sky app and look that way. It doesn't work that way.
Nope.
You need to be able to realize, you need to have it into your mind that, okay, I'm looking in Libra. That doesn't look right. That's when you start thinking, maybe you're seeing something. Start looking on the internet, see if anybody else has spotted anything. If they haven't, report it.
Yep. Reaffirm your observations, obviously.
Yeah.
Get somebody else to show where it's at in case it's a planet that's always been there. You just didn't notice it. It happens a lot.
Well,
I do have a list of supernova currently going off all around the universe. This is a great reference for supernovas. This one lists all of them. In fact, there's probably like a dozen every day across the universe visible from here, but most of them are in pretty far away galaxies, and most of the supernova are pretty far, really on a faint end of like 14th, 15th magnitude, so really tough to see. Let me put that link into our chat room. It's a good reference for how many supernova actually go off during the day. They're all listed here. This is from the Rochester Astronomy Club. It's a great list of current supernova, but they're really, really faint.
And of course, the other thing is, even if you don't spot it as the discoverer, you can get your name on it as being somebody who's confirming it.
Exactly.
And that sometimes is just as good as having it as a discovery, because you're listed up there. Okay, so it will be I'm just going to pick names at random. David Levy and Eugene Shoemaker have found a new supernovae. Okay, I'm going to say that Starstorm was out the same night, and she has confirmed the observation of Messrs. Levy and Shoemaker. Mm-hmm. That is just as good as being the discoverer. Same with comets. When you say if David Levy found a new comet, getting in there with a confirmation, or even better, a confirmation image, and giving all your information, it goes to the Minor Planet Center. They put all your observations into the formulae. That lets them set up an orbit, and that is the important thing. Your name is now linked to that comet because you were confirming the discovery of Messrs. Levy and Shoemaker. I'm just using those names for example because we all know them to be big comet guys. Yeah, well, like I said, with a couple dozen supernova going off a day, they need lots of confirmation. Yeah. So that's really important. And it's also important for us to get ready to get out of here because we're just about at the top of the hour. So I think it's time to send the signals to the mothership. USS Bosman, Captain Zapik. The away team is ready to come home. Being Marty, myself, and Starstorm up, please.
All right. I want to thank everybody for listening in tonight. Don't forget, we got more programming coming up after the Event Horizon, so stick around and of course, thanks to everybody in our chat room for being with us tonight. We'll be back again next Friday night. So,
clear skies all.
Clear sky. Get some observing in. Well, unfortunately, it's a full moon weekend. So, all right, you're not going to do the deep sky stuff, but
go look at the Mare.
Yeah, lots of planets to look at. Mercury. Don't forget to check out Mercury. Good night, everybody.
Good night.
We hope that you've enjoyed this program from AFM Radio, the broadcast service of Astronomy.FM. This program has been released under Creative Commons license. Please contact us for details. You may find more of our AFM original programs on our website. It's really easy to find us. We are Astronomy.FM. You may also find us in the iTunes radio listings near the top of the News Talk section, and also as an iTunes podcast selection. We'd love to hear your comments. Please email us at radio@astronomy.fm. Thanks so much for being part of the voice of astronomy around the world and across the known universe. This is Astronomy.FM Radio.
Hi, this is Tavi Greiner, Astronomy.FM's Vice President of Communications. If you enjoy our programming, please let us know with a donation to Astronomy.FM/donate. We really do rely on your support, and it's true. Every little bit counts.
AFM.
There I was, doing my thing.